Hello and welcome to Barkland Labs. Today we are talking about a Newton's Law lab. This really incorporates all of Newton's laws, but particularly Newton's second and third laws. So, the materials involved. I'm going to call this a Newton's car or a Newton's slingshot. It's just a piece of wood that I cut with a couple of nails that I put in here. Got to be really careful. I almost impaled my hand on a nail. Those are they're still sharp, even though it's the other end of it that you could hurt yourself. So be really careful to not impale and avoid any impaling in this class. Other safety issues to be aware of. Got to make sure that you are wearing your safety goggles at all times. And then I want every group to also have just a wet paper towel with them. Shouldn't be left out in the hallway, but this is because we are using some fire in this lab, and if something was to catch on fire that you wanted to douse really quickly, it's just nice to have something on hand that you can quickly just put it out with. Okay, so the Newton slingshot involves reducing the force of friction by placing some dowels. This is a dowel right here. This is not a percussion instrument, which is what it's going to be tempted for you to turn this into. It's not an implement to strike your buddy with. This is just a way of reducing the friction so that this Newton slingshot can roll along kind of like a car. If this proves to be too difficult for you to work with, I can give you a very small dowel that will no longer work very well as a striking instrument. So, you take your slingshot and you need to set it up by tying a string. So you've got a piece of string here, and you're going to tie a loop. And I want you to shoot for making your loop about the circumference of a golf ball or so. You'll see why that size works pretty well. And I'm going to show you kind of a bad example, and hopefully this is going to be a good example for us. So that's maybe a small golf ball, about yay big. I'll put that next to my hand for scale. There we go. And I'm going to go ahead and cut that off right there. So now that you've got that ready, what I want you to do is I want you to, on your piece of paper, actually draw how big that circle is, because this is a massive control variable that you want to make the same size loop every single time. So you're going to grab your rubber band, and you put your rubber band through one of the nails, or around one of the nails, and then you can actually put it through your loop. Okay, if I can figure this out. Put it through your loop like that, and then connect it to the other nail. So now it will be going down like that, and what you can do at this point is you can pull the rubber band down that way. Now you want it to be seated a little bit higher on the nails, and same thing with your string, a little bit higher. Notice we've got some gap between the rubber band and the car. And then what you will do is you will put your ammo, which is a cube, onto the slingshot. The different kinds of cubes we have: lead, which is obviously very dense, so this cube is pretty heavy. We've got acrylic, which is not very dense, so very, very light. We've got aluminum, copper, brass. We'll actually make some brass later this year. Steel, which is mostly iron, a little bit of carbon, and I think that is it. Yeah, so you've got 6 different blocks. You're going to actually use the scale to find their masses, and what you will do is you will go ahead and place those blocks inside of your rubber band. Now, I'm hoping that you see that the size of the circumference of the string you tie will affect how far this block is pulled back. So the reason it's a huge control variable is if you're tying different lengths of strings, you're going to be applying different forces to this block every single time, and you want to be as consistent as possible with that force. So we've got the copper block on here now. You can set it on the front of your dowels. So if I move this, you can see the slingshot is aimed that away. And you are going to now grab the flame Notice these are set apart maybe about 3-4 centimeters. You don't want to do really any closer than that or any further than that. That's another control variable, though, is about how far you spread these devils out. So now what you're going to do is you are going to put the flame over here, and okay, so our car went off the table. I knew that would happen. You're not going to do this on the table. You're going to do this out in the hallway or in the classroom, depending on where I assign you. And what you are going to measure are two things. You're going to measure how far the cube flew and how far this block itself flew. That's going to tell us something about both Newton's second and third law. The fact that this car went that way while the block went that way is demonstrating Newton's third law, the idea that for every action there's an equal and opposite reaction force. But they didn't go the same distances, and that has to do with Newton's second law, the idea of F equals ma. The amount of force is equal to the amount of mass times the acceleration. The car and the block, and then as you change the mass of the block, it will change something about that reaction force. So you are going to measure how far the car goes, and you're going to measure how far the block goes as a way of measuring the force applied on each object. So we're not directly measuring the force, we're kind of indirectly, by proxy, measuring how much force is applied to the block. The assumption is that if more force is applied, it'll go further, or if less force is applied, it won't go as far. And that's how we're going to illustrate Newton's second law. So going back to the safety things, sometimes your string can stay burning after you're done, so you want to grab that paper towel just in case this is catching on fire. We don't want to start any fires in the hallway. I don't want to get a reputation as that teacher whose kids are always setting things on fire, so you've got this just in case this is on fire, and you can go ahead and douse that. Obviously, you do not want to just be constantly lighting this lighter. Only light it for when you actually need to light it, and you'll notice that this is duct tape. That is not a style points there. That is because somebody broke this lighter, and I've got several of these that were broken in the last couple of years. So just be careful with these. You can snap that if you are not being careful. You can see that is shifting. It still works, but let's just be careful with that. So once again, Newton's second and third law. And Newton's first law is being illustrated by the fact that this was motionless until an unbalanced force was working on it. The unbalanced force was the rubber band pushing that way, and it moved the other way. So that was Newton's third law, and then they moved different amounts based on Newton's second law.